Hi, I'm Paul Morin with the Energy Conservatory, and welcome to our webinar titled Exhaust Fan Flow Meter. We'll go over some housekeeping items first. If you're having trouble with the audio, go up to the meeting pull-down menu and choose Audio Setup Wizard and go through that process, and hopefully that will take care of that issue. And feel free to type in questions as you think of them as we're going through the webinar, and we will be typing in answers during the webinar, and then we'll have a session at the end where we'll review those questions and take new questions at that time at the end of the webinar. The webinar is being recorded and will be available on our YouTube site. The easiest way to get to that is to go to our website, energyconservatory.com, and on the upper right you'll see the YouTube icon, and click on that and it'll bring you right to our YouTube site, and you can view all of our past webinars and other videos there. And as always, let us know what type of webinars you'd like to see in the future. Give us some feedback on that. We find that the webinars that are the most attended are the ones that are recommended to us by our customers. So feel free to give us some feedback, and we're trying to keep providing a webinar a month, and we like your input. This webinar is available for BPI continuing education units, for one continuing education unit. And we'll upload, after the webinar is complete, we'll upload that data to BPI, and they'll go through the regular procedure and award you those credits in a reasonable amount of time. We won't be sending out any completion certificates, so just keep an eye on that BPI, log into your BPI site to check your credits and verify it that way. If you haven't already signed up for those continuing education units, email us your BPI number and along with your full name and company name, and we'll make sure that that information gets to BPI. And in order to receive the continuing education units, you need to be logged in using the same email address that you registered with. So, you can't, a group of 3 of you can't watch on one screen and expect to all get credits. You have to log into, each of you need to log into a computer separately using your email address to receive credits. Our agenda today, we'll start with just a basic intro to the exhaust fan flow meter. We'll talk about the testing procedures, measuring flows greater than 125. The limits of the exhaust fan flow meter is 125 CFM. So we will talk about some methods for flows greater than that, and then the question we get the most from our customers is how do you measure the flow through those pesky range hoods. So we'll be talking about some different methods and options that will allow you to do that in most cases. There are some cases where it's just conditions just aren't right and there's not a practical way to get an accurate flow. So the nicest thing about the exhaust fan flow meter is you can get quick, accurate measurements. It's really easy to use and really quick and accurate. We recommend the pressure gauge you're using should have a resolution of 0.1 pascals. Between 1 and 8, all the measurements you're taking will be with a pressure in the box between 1 and 8 pascals. So you need to be able to measure with the correct resolution between those numbers. And the range of measurements you can take is between 10 and 124 CFM, and you'll get a 10% accuracy when using a 1% gauge, like a DG700 or a DG3. It has 3 calibrated openings, so you adjust the openings based on the amount of flow you're expecting. And it has a handle that velcros on to the box. Some of our older ones originally had a handle with a suction cup, but we got away from that, and now we have a handle that velcros onto the box, and we do sell those separately if you're looking for something like that. So, and there is an extension, an inlet for an extension on the end of that short pole. The pole is about 8 inches long. It's got an adjustable angle on it, and it stays pretty firmly once you've adjusted that angle, and it has a standard painter's pole end on it. So you can, if you've got a standard painter's pole or a broom handle, it will screw into that opening. It's not a proprietary opening, it's just a generic fitting that'll allow you to connect a pole to it. So as I mentioned, there's 3 door positions, 1, 2, and 3. So you'll select your door position based on what you estimate the flow through that fan is. If you don't have a sense of what the flow of that fan is, it's best to start with E2, because most fans you're going to be measuring, most bath fans are going to be in that E2 range of 21 to 59 CFM. So that's always a good place to start. If you've got a flow less than 20 CFM, then there's something seriously wrong. I mean, the minimum I've seen on ratings on fans is about 50 CFM. That's pretty typical. And if you're getting flows of less than 20, there's an issue with a stuck damper or a compressed hose, tubing, or the venting, whatever they're using to vent the fan out has got a kink in it, or a bird nest or something pretty serious. Pressure should be between 1 and 8 pascals in order to get an accurate reading. So if it's not between 1 and 8 pascals, then you're going to want to adjust that door opening. And there's 3 positions. If the pressure is greater than 8 pascals, you need to relieve that pressure. And you relieve that pressure by making the hole bigger. So you want to open that gate to a larger setting if it's greater than 8 pascals. And if that reading is less than 10 pascals, it'll be reading low on the gauge, and you'll want to close it more to get the pressure higher. So greater than 8 pascals, open more; less than 1 pascal, close it more. You'll connect the tubing to the box. The way I like to do it is to use that T connection. If you've got a blower door or a duct blaster system, that came with a T connection with 2 short pieces of tubing on it. And what that allows you to do is connect those 2 short pieces of tubing to the input on channel A and B, and it'll be displaying the pressure on that flow box on both channels. And the advantage to that is you'll be able to see on channel A what the pressure in the box is, and then it'll read flow on channel B at the same time. So you won't have to connect to channel A first to see what the pressure in the box is, and then switch it to channel B to read flow. You can just see both readings at the same time. So you'll connect the tubing to the box, connect the tubing to the gauge, and place the meter over the grill, and it must make a tight seal to get an accurate measurement. So keep that in mind, that if the grill is bigger than the box, you've got to make some some adaptations like taping the box to the ceiling or sealing around that edge some other way. In order to get an accurate measurement, you must be, you need to be accurately reading the pressure caused by the flow going through the fan, and that will only happen if it makes a tight seal. So first step in getting your gauge set up, we'll turn on the gauge and configure it, and we'll start by setting the mode to pressure flow. So here's the mode here, and the mode button, we'll press the mode button once and we'll go to pressure flow. So now our mode is set to pressure flow, and next we'll change the device to EXH. So we start out with blower door 3 as the default position. We'll push the device button 1, 2, 3, 4, 5 times. So the last position is EXH. So that's what we're looking for, the device set to EXH. And then next we'll go to config, and we have a choice between A1, B2, or C3. As soon as we go to EXH, we're seeing A1 on the config, and you notice we don't see open here. Open isn't the first one. A1 is the open position with that gate opened as far as it can be. And then when we push the config button, we'll move to B2 or C3. So now we've got our gauge all set up, and if you're using a gauge that isn't a pressure and flow gauge, that has the exhaust fan flow meter as an option, then you will use the chart on the side of the box. So there's a chart that has one column for pressures, so this is the pressure you're reading off of the gauge, and then depending on whether you're set to E1, E2, or E3, you'll see the flow there. So if we're at 1 Pascal and we're set to the open position, E1, it'll be 44 CFM. If we have the gate set to E2, it'll be 21. E3 it'll be 10. So you'll find the pressure and then follow it across to which setting you have. For flows greater than 125 CFM, there are a few options on how you can do that. You can fabricate a larger flow box, use the Duct Blaster Fan as a powered capture hood, or a blower door pressure matching method. We'll talk about that. Many of you may not be familiar with that method, but in some situations that's an option. So if you want to fabricate a larger flow box, then you'll use the flow through the orifice equation to calculate the flow. So you won't have a calibrated box, but you'll be able to get a pretty good idea of what the flow is based on this equation. So it's 1.06 times the square root of the pressure that you're measuring in that box times the area of the hole in square inches. So if you have a hole that's 5 by 5, that'll be 25 square inches. If the pressure in the box is 1, then that's what your flow is. You're just, I guess you would multiply by 1.06 times the square root of the pressure times the area of the hole. So that's the formula you'll use based on the size of the hole you have. The depth of that box you're using, it needs to be greater than the largest dimension of the hole. So remember that. You can't use a shallow box. You're not going to get the laminar flow is going to throw you off, and you're not going to get an accurate reading. So the box needs to be at least as deep as the largest dimension of the hole. Measure the pressure in the corner of the box. Again, the pressure in the box should be between 1 and 8. And the reason we choose those numbers 1 and 8 is if it's more than 8 pascals, then you're starting to restrict the amount of airflow through that hole. You're creating too much back pressure, and you're not going to get an accurate reading. And it should be at least 1 pascal in order to get enough resolution to get an accurate reading. So that's why those numbers are chosen. So you want the pressure in the box to be between 1 and 8. And an example of a box would be just go 1.5 times the dimensions of the exhaust fan flow meter. So then you'll have you'll have something similar to what the exhaust fan flow meter is, where you have a hole that's off to one side of the box and you're measuring pressure over on the other side. So that so the box size, if you're going 1.5 times the dimensions, will be 18 by 24 by 13 inches deep. So that'll be the size of the box. And the hole in the box will be 9 by 10.5, and you'll have the hole off to one side of the box, and you'll measure the pressure on the opposite side of where the hole is. You want to get over in a corner where you have real stable readings. So that's a pretty good way to get flows between 100 CFM and 280 CFM. So there's a little bit of overlap from that to from our exhaust fan flow meter. So that gives you a pretty good range between 100 and 280 CFM. You can use the Duct Blaster Fan as a powered capture hood, and that's explained in chapter 13 of the Duct Blaster manual. So that gives you some more information, details on how to fabricate that box, and you can use this for measuring supply readings also. So kind of the theory behind this box is when you put this box over an exhaust fan, it is going to be causing a restriction. So you'll need to pull a little bit more air out of the box to make up for that restriction. And you're measuring the pressure at the corner of the box, and you want to get that pressure down to 0. So it's back to the same pressure as it was before you created that restriction. So in this photo, we're showing the duct blaster set up for pressurization. You see this is the side with the flow sensor on, the side with the rings on, and for measuring exhaust fan flow, we're going to need to turn that fan around. So we're going to be pulling additional air out of the box. This is the inlet side of the fan, the side with the rings on. So you'll need to follow the procedure for doing a depressurization test with the Duct Blaster Fan. And for those of you who aren't doing that all the time, you need to make sure you have the flow sensor in there, and the flow conditioner. I mean, you have to have that white flow conditioner with the holes in it, and you need to have 4 feet of straight flex duct before the air goes into the fan, so you're straightening out that airflow before it goes across the flow sensor. And you need to connect an extra tube going to that round transition piece that makes the connection between the flex duct and the Duct Blaster Fan. And on that round transition piece, there's an array of tubes with a T connector, and you'll need to run a tube from that T connector to the reference on channel B on your DG700. So that's the tap on the lower right side when you're setting it up for depressurization. You want to construct that flow box so it's twice the dimensions of an exhaust fan grill. So length will have to be twice, width will have to be twice, and then the depth of it needs to be the average of the length and width of the box. So keep all those things in mind. And this is in, if you don't have the Duct Blaster manual, you can download it from our website, and that's free, and you can review these instructions in chapter 13 of the Duct Blaster manual. And then you'll want to choose the ring to match the estimated flow. So you can measure flows up to 1,000 CFM with this process, and measure the box at the open corner. So you can see where we're connected in here. You're measuring it down at that corner, and you want it to get it to zero pressure at that location. So you'll cover the grill with the box and turn on the exhaust fan. And again, you need to have a pretty tight seal in order to get an accurate measurement. Although it's not as critical, because you're going to have zero pressure at this location, and if you have zero pressure, you're going to have zero flow. So a really tight seal isn't as important with this method. And then you'll turn up the Duct Blaster fan to zero out the pressure. So, even with the Duct Blaster fan off, when you put this over the box, you'll be reading over the grill. Before you turn the Duct Blaster fan on, there's going to be flow through the Duct Blaster, so you're going to be getting a flow reading, and then so you'll be getting a flow reading, and as you turn up the Duct Blaster fan and get it to zero, then you'll get that accurate. You'll get an accurate reading. Or we do have the flow blaster attachment for the Duct Blaster fan, which converts the Duct Blaster fan into a powered flow hood with a battery powered speed controller, and that device makes it easy to measure the flow through an exhaust fan up to 300 CFM. So that gives you more of a range if you've got the flow blaster attachment for the Duct Blaster fan. Another method for measuring flows greater than 125 CFM, I'll call the blower door pressure matching method. And this method will work best if the fan you're trying to measure will depressurize the house by at least 3 pascals, and the wind is fairly calm. Then you can use this method and get a fairly accurate reading. You'll need ring C if the exhaust fan flow is less than 300 CFM, because with ring B of the blower door, the lowest reading you can get is 300 CFM. So you may need to use ring C, or you can certainly use the Duct Blaster fan as the blower door. In this case, either fabricate a piece of cardboard and install it in a window, or we do have a red nylon panel for the blower door with a hole in it for the blower door frame, with a hole in it the size of the Duct Blaster fan. So you can use the Duct Blaster fan for blower door tests up to about 1350 CFM. So that's always an option if you're testing tighter homes too, if you've already got a Duct Blaster fan. So you'll set up the blower door frame and the fan, and you'll pressurize the house. So remember, when you're pressurizing, you have to turn the fan around. You have to turn the fan around, and because we're using it to measure flow, you can't use the reverse switch on the blower door fan. You need to turn it around, so now the rings are on the outside. So there's a few steps in there. You have to take a baseline reading, and now your rings are on the outside. So either you have to run around, go out another door and cap the fan, or if we do have fan caps that are like shower caps that fit over the blower door fan, or you could use just a piece of cardboard or something on that order to cover the fan to get a baseline reading. It's very important to get a baseline reading to get a sense of how windy it is, and it's important to zero out that pressure to start with, so to get an accurate reading. So cap the blower door fan and enter the baseline into your DG700, same way you would for a blower door test. Turn on the exhaust fan, uncap the blower door, and increase the flow to get it back to 0. So you're gonna want to read 0 pascals on channel A, and then the flow through the blower door will match the flow through the exhaust fan. You've zeroed out that pressure, and those flows will be equal. So that's an effective method. As long as your house is tight enough and your fan is big enough to depressurize to at least 3 pascals, you'll have pretty good resolution there. Measuring flow through range hoods. This is kind of the holy grail of trying to measure airflow. Is how do we measure flow through range hoods? Some of the problems that you're aware of if you've tried to measure airflow through range hoods is all range hoods aren't created equal. They're not all the same size. There's some typical sizes, but they're not all the same size. And some are pretty greasy if you're in an existing home, so whatever you're using to try to measure the airflow, it may be a one-time use, or maybe you have to put some tape over it to cover the greasy ends or something. Some have multiple inlets, which make it particularly difficult. Sometimes those inlets hang down below the fan, which makes it more cumbersome to try to get a measurement. You have to be creative on creating a box that will cover that opening and still allow you to get a flow reading. Microwaves and downdraft ranges are particularly tricky, and you'll have to fabricate some kind of specialty device to get airflow measurements out of those types of things. In a one-size-fits-all device or a one-size-fits-all procedure, it really is not going to be possible. So you need to be flexible and do different procedures based on what you find, what the conditions are at that house. So for flows less than 125 CFM, it's pretty straightforward. You can fabricate. You'll need to fabricate a custom plate based on the size of that opening. So if you're measuring flows in a condominium complex and all the range hoods are exactly the same, you can spend some time making a really nice tight-fitting plate, and then have a hole in it the size of the exhaust fan flow meter. And these photos were courtesy of Mike Dunseth with the Green Jobs Training Center, and he fabricated a really nice one for his training center there that'll fit their range hood. And you can see he connected some pieces on the side here so the exhaust fan flow meter will fit tight to that. So when you pick up the exhaust fan flow meter, that plate will be attached, and it fits really nice into that range hood opening, so you can get a really accurate measurement through that range hood. And then he also added some Velcro to the exhaust fan flow meter box, and you could put that on the top or on the side, so you can kind of do a one-handed operation where you just grab the handle, put it up against the box, you can see the gauge and get a reading pretty slick. For flows greater than 125 on a range hood, you can use that larger flow meter box like we talked about, fabricate one that's 1.5 times the opening, and cut opening just smaller than that in the plate, and cover that over the opening to get measurements larger than 125 CFM. And it is important to have that depth. You know, we talked about the depth of the exhaust fan flow meter being at least as big as the opening, the largest dimension of the opening, to allow that flow to kind of equalize and straighten out before it goes through the hole. It's important to have that aspect when you're measuring flow through a range hood. So you can use a plate to cover the opening, cut a hole in it, size of the flow box you're using, and get a measurement that way. And again, you're going to have to fabricate, you know, a plate that's going to cover that whole opening, and then you could use the Duct Blaster as a powered flow hood in that same type of fabrication. And again, you'll want to fabricate a box that will be coming down from the range hood, and then you could connect the Duct Blaster fan on the side facing you, so it doesn't have to be on the bottom. It could come out the side of that box. But again, you need to have the plate that covers the range hood opening, and then a box coming down from it. Connect the Duct Blaster fan to that, and you can get some pretty accurate readings that way. Or use the blower door pressure matching method, again, that we talked about. If that kitchen fan depressurized the house at least 3 pascals, so you have to have either a fairly tight house or a fairly big kitchen fan in order to get that amount of depressurization, and the wind needs to be pretty calm. And what I would recommend for determining if the wind is pretty calm is set your gauge to 5-second averages. So set the time average to 5 seconds and write down 5-second averages. So it takes 30 seconds, 25 seconds to take these readings. Write them down. And if the range, the difference between the highest and lowest of those is less than 0.5 pascals, then you're going to get pretty accurate readings. If it's larger than 5 pascals, then your accuracy is going to start dropping off fairly quickly. So that's, you know, on any day when you're taking CAS pressures or whatever you're doing, it's a good idea to see how accurate your numbers are. If you're spending a lot of time trying to take really good numbers and you're writing down what the DG700 says, but you've got a range of 4 pascals between the highest and lowest of these 5 readings on a day when you're trying to measure 3 pascals, you know, you're kind of wasting your time, really. I know you have to write down some numbers, and that's fine. I'm fine with writing down the numbers if you're required to write down numbers. But also write down these 5-second averages so you get just a quick glimpse of what the wind is doing during that time when you're taking the measurements. Now we're going to go over a review of those 3 methods we talked about for measuring range hood flow. The first one was using a larger flow meter box with a plate over the opening. So that flow meter box that we talked about, that was 1.5 times the exhaust fan flow meter box. We're gonna cover over the opening of the range hood and attach that box to take a measurement. So the first step is to cut a piece of cardboard or some kind of material to cover over that range hood opening. In this case, I just use some lightweight cardboard. You may want to use you know, either heavier gauge cardboard or some other kind of material if you're using it on a you know, more permanent basis. But you're going to find that range hood sizes can be all over the place. In this case, the range hood opening is 42 by 17. Standard range hood size is going to be 30 inches. So most common ones you'll see in an average home is going to be narrower than that. And if that's the size you see most typically, you might you might want to get something that's a little bit more durable and more permanent. But you're going to have to be flexible and have some material on hand that that you can cut to a custom size, because they're not all going to be the same. That's what makes measuring range hoods difficult, is the amount of time taken to fabricate everything you need to take a measurement. So in this case, you cut a 42 by 18-inch piece. You know, it's fine if it sticks out farther, but it does need to fit side by side well. And then we cut a 20 by 14-inch hole in that to work with the box that we had. And I happen to have some cardboard angles that came in some packaging on something that was purchased recently, so I used what I had on hand, and I cut some of those angles so I'd have a rigid opening the size of the box, and that does a couple of things. It makes that cardboard more rigid, so it's more durable when you tape it up there, and it also gives you something else to connect that box to. So I recommend doing this if you've got some of that kind of material around and you're using the same size box all the time to measure airflow. You've got that box that you're using that's 1.5 times the dimensions of the exhaust fan flow meter to measure bath fans that are over 125 CFM. You can also use it in this application, so you can have those angled pieces with you to make that more durable and to make that connection to the box more durable and easier to make a connection. So this is an example of that flow box that's 1.5 times the flow meter. It'll work for measuring flows from 100 to 280 CFM. Remember, you want that pressure in the box between 1 and 8 in order to get accurate measurements. At least 1 pascal, so we're getting enough resolution on our reading, and not more than 8 pascals, or you're going to start restricting the flow through the box. So we fabricated that just out of lightweight cardboard again. If you're going to be using this on a regular basis to measure exhaust fan flow and kitchen fan flow, it's a good idea to start out with cardboard, because now you've got something you can use tomorrow with something that's readily available. But long term, it's going to be better to fabricate that out of something that's going to be more permanent. Then it's not just something that's taking up space in your truck or your car. It's something that you'll be able to use. You know, you could put a piece of cardboard in the bottom of this box so stuff doesn't fall through the hole, and then you can throw your exhaust fan flow meter and your pressure pan in there, maybe some tubing, and now you've got a box that's usable for carrying things into the house. And it's not just a cardboard box; it's going to get busted up over time. And you could put a gasket on there, so it makes a tight seal against the ceiling when you're taking bath fan flows, and then you've got something that you can also use for kitchen fan flows. Then we taped that box up in place and added a tube in the corner. Now we're ready to take that measurement. I'd recommend bringing something to prop that box up, because especially if you're using heavier materials, tape isn't going to stick. Sometimes you're going to be trying to tape to greasy surfaces that won't work so well. So you're going to want to bring some things along that you can use to prop that box up, to hold the weight up so it doesn't come down in the middle of your measurement. If you've got larger flows, you know, if you've got a cardboard box, you can make that hole bigger. or you can make that hole smaller by taping it using some duct mask or tape or cardboard and tape to make that hole smaller. Because remember, the first step in taking the flow using this device is to make sure that the pressure in the box is between 1 and 8 pascals. So you'll need to make that hole either larger or smaller, depending on what your initial pressure is. So that gives you some flexibility of using a cardboard box. Is you can always make that hole bigger or smaller pretty easily. If you're going to make a more permanent box, maybe you want to start out with a slightly larger hole. It'd be nice to have a slide on it like the exhaust fan flow meter, but I'm not sure how often you're going to see flows over 280. For kitchen fans, this will work much of the time. But you may want to, if you've got a more permanent box, you may want to have a more permanent tap that you can connect your tubing to, instead of just having a hole you're pushing your tube through. Eventually that's going to become loose and your tube's going to fall out. We do have those bulkheads that we use, so you can, it's got a screw on the top side, and you can permanently fasten that bulkhead to the box, and then you've got that brass tap to connect your tubing to. Okay, the second method we talked about was using the Duct Blaster Fan as a powered flow hood. So in this case, I used that same box. I mean, it's the right size to make it work, and I just used some duct mask to cover over the lower hole on it. And now we've got a second option for measuring flow. And remember, the Duct Blaster Fan can move up to 1300 CFM airflow, or even more than that, really, because the kitchen fan is doing part of moving the airflow. So now we're moving air at no resistance. So you can measure flows of very large exhaust fans using this method. So we're just using that square transition piece, putting that up against the cardboard and drawing the circle so we have the size of the hole, cutting that circle, taping the square transition piece to the box, and then using the Velcro strap to connect our tubing, our 10-inch flex tube to that square transition piece. And we're measuring the pressure at the same location, and we're ready to go. So this process is very simple, where you'll turn on the kitchen fan. In this case, I needed to reach through that hole I just cut to turn the kitchen fan on, right? Because the controls are covered up by the box. So remember, when you're putting that box on, that you have to still make those controls accessible to turn the kitchen fan on. So we turn the kitchen fan on, and this whole device we've attached now is going to create some resistance, right? It's gonna the kitchen fan is gonna make the pressure in that box more negative, because it's trying to move that same amount of air that it did at free air. So we're gonna initially, when we get to our DG700, the kitchen fan is running, we turn on the DG700, we're going to see a negative pressure in that box, because this has created some resistance on the airflow. And then we're going to want to get the correct ring on there for the amount of flow we're estimating, and turn on the Duct Blaster Fan and bring that pressure back to 0. So now there's no pressure difference between that box and the air, so we're at the same condition we were before we put the box on, and we're set up to pressurize that space. You can see the flow sensor on the fan, and the rings are facing towards us. We're pressurizing that space. So what we're doing is we're reading a negative pressure in that box, and we're going to, as we blow air into it with the Duct Blaster Fan, we're going to see that pressure move towards zero. We're blowing air into it, we're pressurizing it. We're going to see that pressure move towards zero, and when we get at zero, we're going to measure our airflow. So, you know, if we've already got our box prefabricated, and you know, we just need probably, in most cases, we'll have to fabricate that plate because it'll be a custom size for that range hood. And this one solves that problem of sometimes range hoods have fans that stick down below the level of the bottom of the hood. And you know, in this case, we've got a big enough opening, so it'll solve that the issue involved with that. So that's our second method, using the Duct Blaster Fan as a powered flow hood to get our measurement. And then the third one was pressure matching using our blower door fan. So if we're going to do that, the kitchen fan, really, in order to get an accurate reading, we're going to want the kitchen fan to be able to depressurize the house by 3 pascals. So kitchen fan should change the pressure in the house by 3 pascals. And if it does, then we've got a good candidate for this method. And we want to make sure it's not too windy outside. So those are kind of the 2 criteria we'll use to determine if this is a good method. If we've got a kitchen fan that'll depressurize by 3 and it's not too windy. We talked about a method to determine how windy it is. We'll set our DG700 to a 5-second average, and we'll write down those 5-second averages. So this isn't our method of taking a baseline reading. This is just a method to determine how windy it is. And I recommend that when we're doing CAS tests also. Quick, easy way to determine, just get a snapshot in time, how windy is it on a given day. Then we'll set up our blower door to pressurize. If you haven't done this before, it involves turning the Duct Blaster Fan around. We're going to be using the Duct Blaster Fan to measure flow. So we can't use the reverse switch. If you've got an older fan with a reverse switch, you can't use that reverse switch to measure airflow. And in this case, we're using the fan to measure airflow. So we need to turn the Duct Blaster Fan around so our rings are on the outside of the house now. We need to run an extra tube for the fan reference. So we need an extra tube going to the outdoors, going to the lower right tap on your gauge, the fan reference pressure, the channel B reference, is where we want to connect that tube so we get accurate blower door reading in this case. Then we're going to have to cap the fan, and if you don't have one of those shower cap like fan caps, you'll need to cover that opening. Either go outside and cap the fan, come inside, enter your baseline reading, and then go back outside and uncap it, or you'll need to seal that blower door opening from the inside to get your baseline reading. It's important to get that baseline reading entered into your DG700 for this measurement in order to get an accurate measurement. Next step is we'll turn on the kitchen fan, and now our DG700, we're going to be reading hopefully a negative pressure of over 3 pascals, and then as we turn on the blower door fan, it's going to pressurize the house and bring that pressure in the house back to 0, and then we take our reading. So that's our third method. So as a summary, for sure, there's not one method that's going to work in every case. So the first determination you're going to have to make is what is possible on this house with these circumstances, with the range hood. What of those three is possible, and determine what you think is going to be the most accurate method, and thirdly, what's going to be the most efficient. So if you're at a house and you've got a kitchen fan that's depressurizing the house by 8 pascals and it's a dead calm day and you've already got the blower door set up, why wouldn't you? The most accurate method in that case is going to be use your blower door to determine the airflow of the kitchen fan. Those are ideal conditions. And that's going to be your most efficient, your most accurate way to get that measurement. If you've already got a box set up to work, and you've got a duct blaster fan, you've already got the duct blaster in the house, you've got that box you use for that pressure matching method using the duct blaster fan as a powered flow hood. Then you may find that that's going to be the best situation to use. If you've got if you've got the flow box and it's a standard 30-inch wide range hood, or a real standard range hood, and you've got that set up all connected, then that may be the best. So you'll just have to be flexible, and not one method's going to work in every case. So kind of think through in this order, what's possible, what's going to be the most accurate, what's going to be the most efficient. You could spend an hour fabricating and attaching something if you're starting from scratch. It may be even more than an hour, depending on what kind of materials and workspace you have available. So over time you're gonna gain more tools and more things to use to measure these airflows, and hopefully you'll come up with some really good methods to give you maximum flexibility and the ability to get accurate readings. So that summarizes methods of measuring exhaust fan flows using the exhaust fan flow meter, and some other methods for measuring kitchen fans. We'll have some time for questions now. We can review some questions that have already been asked. And we have time to take some new questions. Thanks for attending our webinar, and we're always looking for suggestions for new webinars. We find those are the ones that are best attended, or the ones that are recommended by our customers. So please send us some suggestions on what you'd like to see for future webinars.